Good evening. Welcome to
SummerMath number 7.
SummerMath number 7. So we have been studying a new chapter.
Yeah.
And we moved to a new section on permutations today.
Yeah.
And I'm going to talk about permutations and a related thing called combinations. Okay. So say we put 5 different blocks in a bag. Do we have 5 different colors? Oh yeah, black. And hopefully these colors all look different on camera. I hope they do. The brown probably looks a little bit like the black. Do we have a different color? Maybe the orange?
Okay.
Sweet. That won't look the same. And what we're going to do is we're going to pretend we put these in a bag.
Okay.
And we're going to pull them out of the bag and put them on pedestals.
Yep.
And the thing that's going to be special about this is when we put them on a pedestal like that, say, number 1, number 2, number 3.
Yep.
We're going to think about this as being different than something like that. Even though we have the same colored blocks, it's just there's a different one on number 1, maybe a different one on 2, on 3. Okay. So the first question is, if I have 5 blocks in my bag, how many different ways are there to do this?
Well,
Someone want to take a crack here?
if there's 5 blocks, if you put like these 3 on, this is one case.
Yeah, that's one way of doing
Well,
it, for sure.
And then you can scramble. You can count the ways with this one being in number 1, this one being in number 1, or this one being in number 1.
Okay, yeah, and that would count all the different ways we could do it with just these blocks, but what we're trying to do...
I have an idea.
Well, hold on one second. What we're trying to do is count all the ways you can do it with all the different combinations. So,
How will we do that?
So,
what's your idea?
well, you've got 5 different colors of snap cubes for number 1,
Okay, so I have 5 different choices for number 1.
and then you take one out because one of them went there.
Okay, and then let's ask your brother, what would happen on number 2? How many?
There would be 4 choices
Okay, why is that?
because you took one out,
They took one out, so there's 4 choices
and now
there.
there's 3 choices.
Okay. 3 different ones we can put there. So that would be one arrangement, for example.
Yeah.
So how many arrangements does that mean there are?
5 times 4
times
times
3.
3, which is 60 different arrangements.
60 different arrangements. Okay. Does that make sense?
Yeah.
Okay, now here's a slightly different problem. So this was 60 when once one came out of the box, it just stayed on that pedestal.
Okay.
I'm going to do something a little bit different. I'm going to allow you to put the block that you picked back inside. So if you pick the yellow block, we'll take a yellow block from over here and put it there. So there's still 5 left in here.
Cool.
So how do you think that changes the answer before we compute it? Do you think that means there's going to be more choices or less choices?
I think there's
More.
more because if you put this here, you record the number, then you put it back in. So you could get this for number 2 and for number 3.
For step
Oh,
number 1,
very
you've
good.
got the same number of blocks as step number 1 or the last one. Step number 2, you got 1 more. Step number 3, you got 2 more.
Okay, so how many different blocks might I have in first position?
You're going to have 5,
5.
like we did last time.
Okay. How many for number 2?
5.
5 again. Ooh.
5, so
Yeah,
you get
5.
125.
So when I multiply this together, I get 125.
That's definitely more.
Whoa. Okay, and now here's a challenge problem. You ready for this?
Yep.
What if I didn't care about how they were ordered, so there were no pedestals, so I didn't care what one was number 1, number 2, number 3? What if I just wanted to put them in a different circle over here, so I just picked 3, and if I picked them purple, yellow, orange,
That would be the same.
that would be the same as if I picked them out in a different order. Ooh. How do you think you would do that?
Well,
When you pick one, does it stay in the circle?
Yeah, it does. It does.
so that means it's going to be less than 100. It's going to be less than 120.
Definitely be less than 120.
Well, since order doesn't matter,
You can just pick 3 blocks randomly.
Right, I could just pick 3 blocks randomly. So there's one grouping. Okay?
Yeah.
so maybe we could say we pick orange as our first block.
Okay.
And then you could pick 4 different blocks for the second block.
Right, so I have 5 choices for the first,
4 choices for the next.
4 for the next,
And 4 for the
And
you got 3 for the third.
3 for the third. But here's the problem now, is that this one, let's say it was orange, purple, black,
Yeah.
is going to be the same as if I went black, orange, purple, for example. Okay? So I've counted this one more than once.
Well, like, you can count every set of 3. You can count it 6. You can count every set of 3 6 different ways.
How did you figure that out?
Well, because you got this set, then when you put this in front, you can swap these two. You put this in front, you can swap these two.
Okay, so every set of 3 gets counted 6 times.
That means you have to subtract.
So you have to divide by 6.
You have to divide by 6 because now I'm dividing these into 6. Each set of these 5, 4, 3, each set of the 60 gets divided into 6 sets.
And luckily,
Which
Our-
means it's 10.
because we have 60 here, 20 times 3 divided by 6 is 10.
Okay. So we're going to learn about all different kinds of counting.
Yep.
This is called a combination.
Yeah.
When you just put them all together in the order that doesn't matter. And when the order did matter, when we lined them up on the pedestals,
Yeah.
that's called a permutation.
Cool.
All right.
All right.
Good job tonight, guys. Good job. We'll talk more about that tomorrow.